Hello, and welcome to this Xilinx Quick Take video, where we'll cover Xilinx recommendations for constraining false path, min-max delays, and set case analysis. This Quick Take assumes you have created clocks in your design. Clock creation is covered in the Quick Takes titled Creating Basic Clock Constraints and Creating Generated Clock Constraints. Please see those videos if you need more information. You can also refer to other Quick Take videos titled Advanced Timing Exception, which explain other timing exception constraints like clock groups and multi-cycle path constraints. So let's get started. We'll spend a little bit of time on the different types of exception constraints, followed by a detailed look at the false path, min-max delay, and case analysis constraints. We'll talk about exception priority and a few tips for constraining exception constraints. Finally, we'll summarize what we reviewed in the session. Timing exception constraints are needed in areas of the design where the default setup and hold checks are not valid. The constraints are needed because the design behaved in a way as to make the default checks invalid. Another reason is to direct the Vivado synthesis and place en route to focus on real critical areas of the design. In the absence of timing exception constraints, and since Vivado is timing driven, there is a possibility that the tool will focus on the paths which may be invalid. Omitting exception constraints will cause the tools to work overtime to optimize the invalid paths instead of the real paths, wasting runtime and device resources. The exception constraints are set clock groups, set false path, set multi-cycle path, the set min-max delay, and the set case analysis constraints. In this session, we will cover the set false path, the set min-max delay, and the set case analysis constraints in detail. False path constraint is an exception constraint that can be very beneficial. It allows the tool to focus on real critical paths in the design. With the false path constraint, you can not only disable analysis of cross-clock domain paths in which the clocks are synchronous, but also the analysis on paths that are driven by static signals. Use the command report exceptions to debug and validate issues with false path constraints, if any. The set max delay and set min delay constraints are used to specify timing requirements on a path without defining a clock. Examples of these paths are feed-through or TPD paths. Feed-through paths are paths in the design that feed from an input port through a combinatorial block to an output port. There are no sequential elements in the path, so there are no clocks involved. When there are no clocks involved, Xilinx recommends creating a virtual clock to constrain such paths. Please refer to the XDC language template if you need help with this. The set max delay Datapath only is also used to constrain paths across asynchronous paths. We will review this in the next slide. If the constraints set max delay and set min delay are applied to a path that involves sequential elements, then these constraints would override the existing timing requirements defined by a clock period. The set max delay Datapath only constraints can be used to constrain the data path on an asynchronous clock transfer, instead of cutting the analysis with a set clocks group or a set false path constraint. Merely adding a set max delay data path only is not sufficient on paths across asynchronous clock domains. You must ensure that a proper failsafe mechanism like a synchronizer or a FIFO is present for the transfer to be safe. The set max delay data path only constraint ensures that the data path across asynchronous clock domains are as small as possible. The async reg property on the synchronizer will ensure that the two flops of the synchronizer are placed in the same slice. Please note that the set clock group set false path constraint has a higher priority than the set max delay data path only constraint. This means that if there are set clock groups or set false path constraints applied, then the set max delay data path only constraint will be ignored. In this example, there are two primary clocks, CLK1 and CLK2, that are asynchronous. There is a path from the clock CLK1 to the clock CLK2, which needs to be constrained. Note the presence of a synchronizer in the clock CLK2 domain. The set max delay datapath only constraint is used to constrain the asynchronous path between the clocks CLK1 and CLK2. With the max delay datapath only constraint and the async reg property on the synchronizer, we can ensure that the three registers are placed as close as possible to each other. Keep in mind that in order to use the set max delay constraint, you should have applied the set clock groups or the set false path exception constraint. The set case analysis constraint is used to specify that a port or a pin is at a constant logic value of 1 or 0. It's also used to propagate a rising of a falling transition. Propagating a constant will cause timing paths to be disabled. If it is used to propagate transition, then it will limit those timing paths to that transition. Use report case analysis to report case analysis elements in your design. In this example, the mux select pin cell is set to 1, which causes timing through N0 to be ignored if a set case analysis is set on the mux select pin. If multiple exception constraints are applied, which exception takes priority? SDC-based timers have the following exception priority. The constraints set clock group and set false paths have the highest priority, followed by set max or min delay, then followed by the multi-cycle path constraint. What this means that if there is a set clock group and a set max delay constraint, then the set clock groups constraint will take priority and the set max delay constraint will be ignored. The second type of priority is the path specification priority. Look at the two set max delay constraints below. In this case, the first path is the winner because it's more specific, even though the second one is tighter. Here are a few tips when applying exception constraints. False path and multi-cycle path constraints can be runtime sensitive. If you have all registers, or if you have wildcards in the constraints for false path or multi-cycle, runtime will be affected. Avoid using such constructs and instead try to be as specific as possible and ensure that both the start points and endpoints are valid. For the set min or max delay constraints, ensure that the start and endpoints are valid to prevent path segmentation. Avoid abusing exception constraints to hide real timing violations. Overuse of exception constraints will affect QOR. Debug constraint issues by using the various reporting commands available with the Vivado design software. For example, use report exceptions ignored to debug and validate exception constraints. In this session, we reviewed the various exception constraints and discussed in detail the false path constraints, the set min-max delay constraints, and the set case analysis constraints. We reviewed the exception priority and finally discussed a few tips while applying exception constraints. Thanks for watching.